armchair tilt, right? Looks like armchair on the other direction. Or you fold it in any direction, you form the so-called chiral tilt, right? And this chiral tilt will be semiconductor. Okay? So it depends on the way you fold it, you can make the nanotube behave in the way you want. And not only that, it depends on the diameter as well. Okay? I don't have to go through all the equations and everything. Alright, this is the end of the game. Now let's see what is so interesting about carbon nanotube. Now, can you see here? You have two layers of atoms, right? Two sheets, right? It's just like this is the graphene, right? You fold it to become seamless nanotube. Imagine it's 1 nano. Imagine. Another one. You have a smaller tube. I need 4 pens. That's okay. Now, if you have smaller tubes and you have bigger tubes, you can put this one inside. Coaxial. Then this is called double wall nanotube. 2 walls, right? 1 wall, single wall. 2 walls, double wall. Many walls, multi-wall. Okay. So this is the so-called nanotube. What are the applications? Sky elevator. Have you heard about this before? Never? Okay, here how it should look like. We say carbon nanotube is very strong, right? It can be a cable. A cable to pull elevator to the moon. This is an imagination. Let's say you have the satellite to pull all the carbon nanotubes to the moon. Right? Call it sky elevator. Elevator to the moon. And what is the moon Earth distance? 10 to the power 8 million. Okay? And this is the promises. If you have this, you don't have to fly aircraft. You cannot fly to the moon. You cannot fly rocket. You don't have to build an expensive rocket to fly to the moon. If you build an elevator, if you happen to have it here, right, this will become an attraction spot in the whole Malaysia. Why? Because it's connected to the moon. Especially the new married couple, you come to MMU to ride the elevator to the moon for honeymoon. Okay? So if you work hard, alright, this is your assignment. Build one elevator. Just build one elevator at MMU. But can we grow carbon nanotubes this long? The length is 10 to the power 8 meters. And the world record nanotubes so far is 1 centimeter. So this is your assignment, not mine. It's still hard for me. Okay, so far we can only grow nanotubes to a few hundreds micron mostly, and maximum 1 centimeter. And this is the so-called vertically aligned tubes, which means all the nanotubes are standing vertically aligned, like a carpet. And what is so nice is that this is nano, right? I explained to some of your friends in the first talk. Nano means they have many sticking effect, the so-called Van der Waals force. Alright? So now you have many nanotubes bundled like this. Okay? And now you pull one of the tubes out. What will happen? If you pull one of the tubes out, the next tube will stick to it, right? You follow. And the next tube will follow. And the next tube will follow. All of them will follow, right? Okay, all of them will collapse one by one, follow. And if you twist them, then you pull them out, you will form this yarn. Nanotube yarn. Ladies like yarn, right? To make your shirt or whatever. Okay, yarn. And this is very nice. Look at this. One piece of the yarn. There are many tubes, only a few hundred microns, but they all stick together. You can make 2 of them become like this, 3 of them like this, or any pattern that you want. Okay. Now we say that we cannot grow nanotube as long as the distance to the moon. But in this way, you can make them very long. However, the strength of this one, it could be as strong as the plastic sheet that you have. Only. It's not as strong as steel yet. Don't think about 5 times stronger than steel yet, unless you can grow them to 10 to the power 8 meter long. Then it could be as strong as, or 5 times stronger than steel. Okay? So if you wanted to build elevator to the moon, you need to make cable like this, or the so-called yarn, and make sure that they are long enough to 10 to the power 8. So this is the challenges, right? And this is your assignment, not mine, okay? All right, we talk about nanotubes, right? One tube inside the other, double wall tube, right? So, in fact, the tube inside can rotate inside another tube, right? So, this is a smaller tube, and this is a bigger tube, right? Come on, cylinder. This tube inside, coaxial, you can rotate. You can slide them. This is piston. Okay, all these mechanical parts will be for your future engine. Alright? And in fact, this is one of the actual work demonstrated by UC Berkeley again. They can observe this kind of motion inside the electron microscope. And not only that, they can also connect a piece of metallic plate, right? Just as shown here. This is a piece of nanotubes, right? You connect a metallic plate here in non-symmetry, and then by using S1, S2, and S3, the electrodes here, you apply a probing electric field, you will make the plate turn, right? You actually can make them turn, because if you have a tube like this, right? If you break the tubes, the outer tubes, right? So that the outer tubes will be free to rotate on the inner tubes. Then you can actually rotate them 45 degrees, 90 degrees, 270, etc. 125. Okay? You can rotate them. If you have access to this journal, you can go online, you can watch the video. They can actually rotate it. The question is, it is not easy to build one of this device, right? And it will be in a micro size. To build one, you might spend weeks. And how many this kind of so-called mechanical parts in one car? Let's say in a robot, you have million pieces of this kind of small parts, and not just that simple, right? So the challenge is, can you make million pieces of this motor in a low cost and put them compact enough inside a car or inside a robot? So this is the challenge, okay? And this is your assignment, not mine, okay? Nanoprobe. We say nanotube is very small, right? Your fingers is a probe. You can touch the chain, and you know the shape, right? You can slice on the table, you know the shape, your fingers. But now, imagine that the surface of the table having a nano structure, nano steps. Can you feel it by your hand? Just like this case here. Let's say you have a nano steps like this, right? This is the so-called conventional scanning probe microscopy tip. It's like pyramid shape. Okay? Can you imagine that? Can this, the tips of the probe, can this touch the bottom corner here? Anyone say yes? No, we cannot. We can never, because it will stop by the side wall here. And if you scan this one, it will actually feel like this shape. But the actual shape is square. What is scanned is a triangle shape. So this probe is failed to tell you what is the actual shape on the substrate. But now if you have nanotubes connected to the end of the probe, this is long and sharp, right? So can the end of the tapes touch the bottom edge corner? Can you? You can. So if you can touch this, you can realize the actual dimension on the substrate. Okay? The question is, it takes us